Trigonometry. What do you understand by the name of this section of mathematics? You can say that trio, this is trio, tri. Tri is nothing but a kind of three, and then the metry is something related to measurement or measuring, etc. So we will just try to delve into very basic concepts of trigonometry. So for first of all, what we will do, you know that trigonometry has to do something about triangles, isn't it? And then there are various kinds of triangles. For example, there's an equilateral triangle, there's isosceles triangle, and then there is some triangles which are scalene. Scalene means none of the sides of a triangle is equal. And then equilateral triangle means all the sides of the triangle are equal, isn't it? So for example, the side AB is, for example, 5 centimeter, and then BC will also be 5 centimeter, AC will also be 5 centimeter. And then that is one of the basis of subdividing triangles into various parts or various kinds. There's one more way of subdividing the types of triangles, and that is based on the angle. So here you see we have made a right angle triangle, and in case of scalene triangle, all the sides angle all the sides are not equal, and all the angles are also not equal. And for the equilateral triangle, all sides are equal and all the angles are also equal, isn't it? So there is a kind of relationship between angle, measurement of angle, and measurement of sides, isn't it? So what we will focus upon in this trigonometrical lesson is right angle triangle. And why we do that? The reason why we will stick to right angle triangle, because wherever you see in your room, when you are just going outside, just go outside and see all the buildings, they all are at 90 degree. For example, if you watch a building, for example, if this is a building and you are standing here, for example, at around 10 meter of distance from this building, and someone is watching you from this window, for example, then it makes a certain angle that we can call theta. And here also there will be some angle, but what will be this angle? This will be 90 degree angle. So 90 degree angle is very important, and most occurring angle in the nature, or mostly on the man-made objects, we can say. So it's very useful angle. So what we will base upon our present class is, we will just try to study right angle triangle in this trigonometrical lesson. Although trigonometry is not only confined to right angle triangle, I just want to declare it in the beginning. It is but it is the most important and most simplest one also. So what we will talk about first is something called trigonometrical ratios. Trigonometrical ratios. What is trigonometrical ratio? By ratio, you know that it's a kind of fraction, or it is a division between two numbers. For example, if you divide 2 by 3, then this is a kind of ratio. If there are two things, one is defined by A, another defined by B, and the quantity of A is 2 and quantity of B is 3, or it's not correct to say that. If the quantity of A and B is in uh, for example, if you just divide this quantity, if the quantity of A is 20 and quantity of B is 30, then we can say that it is in 2 by 3 ratio. So that is all about ratio. So here also, in let us make a right angle triangle again. So yes, so this is our right angle triangle which we will try to study. So here we have defined this angle as 90 degree and this angle as theta. And can you guess what angle will be this angle? This angle will be obviously 90 minus theta, because the sum of all angles of a triangle is how much? 180 degree. And if this is 90, means B is 90, then sum of A and angle C should be 90 degree, isn't it? And for this A and C, we define angle C as theta. Theta is nothing but a kind of notation which we will give to some angle, any angle. So it could be theta, it could be A, B, C, alpha, beta, or anything. So angle A in that case will be 90 degree minus theta, isn't it? It is what, this is what it is. Okay, so now we will try to define the sides of this triangle, and there is some underlying definitions also for those sides which we will consider. But before that, let me okay, so now this is our neat and clean triangle, which is right angle, and then there is something called base. Base is, as you know, on which everything else depends upon. So the base, or it is also called B, of a triangle is the side of the triangle on which 90-degree angle and the angle, one of the angle which we have actually defined, theta, both of them lies between. That is called base. That is a basic definition of base. And then the other side, just in front of the theta angle, is called perpendicular, or it is denoted as P. So we will denote it as P later. And then the side which is just in front of 90 degree is called hypotenuse, or we can say H. So here we have defined all the three sides of the triangle, and those are P, B, and H. So we will try to define trigonometrical ratios based on these three sides, or we can say a ratio of these sides. And before that, let me just clarify one thing. By B, we mean the length of the side BC. So, for example, the length of side BC is B, the length of side AB is P, and length of side AC is H. So if this is clear, we can just go forward and read about some other some kind of trigonometrical ratios. So hope this is clear to you. So here we have made a right angle triangle, 90 degree. Let us define the vertices of this triangle, which is ABC. This is theta. So what will be this one? It will be B, or the base. This will be hypotenuse H, and this will be perpendicular. Then there are three identities which are very, very basic. One is called sine theta. This is nothing but a ratio. It is defined by ratio of perpendicular to hypotenuse of in any right angle triangle. So for example, if the length of perpendicular is 10 centimeter and length of hypotenuse is 15 centimeter, then sine theta will be equal to 10 by 15 or whatsoever, 2 by 3 or anything you can assume. And then there is another ratio which is defined as the ratio between base and hypotenuse, B and H, and that is called cos theta. And tan theta is the ratio of perpendicular to base. So basically these are three very, very basic trigonometrical ratios based on which we will learn trigonometry further. But these are one of the basic trigonometrical ratios. And basically on the basis of these ratios, there are some other ratios also defined. For example, those three ratios are called, cosec theta, which is nothing but inverse of sine theta, inverse ratio of sine theta. So h by p. And then there is something called cos, inverse of cos, which is called sec theta. And as you can guess, it is nothing but a ratio of h and b. And then for the tan theta also we define a kind of inverse ratio which is called cot theta, and that is b by p. So these are also three ratios which are in a way inverse ratios of sine, cos and tan. But the basic ratios which we will concentrate upon is sine theta, cos theta, and tan theta. Okay, so hope you are now quite familiar with the trigonometrical ratios. Let us revise all those things before we go further. First of all, we have defined triangle ABC, and then the base is denoted as B, and then there is something called perpendicular, which is nothing but the side in front of angle theta, and then we have side in front of 90-degree angle, which is H. So when we have defined this angle, we have defined three trigonometrical ratios. One is sine theta, another is cos theta, another is tan theta. So sine theta is nothing but P by H, cos theta B by H, tan theta P by B. So after going through all those things and revising it a little bit, we can go further. So actually here now we will concentrate upon just establishing two basic relationships on the basis of between these trigonometrical ratios, sine theta, cos theta, and tan theta. One very basic um, relationship which you can actually guess is that tan theta is the ratio of P and B. So we can also say that, okay, just divide both of them by H. Then what this ratio becomes? This ratio becomes sine theta. And then what this ratio becomes? You can see this is cos theta. So here cos theta. So basically we have a simple relation between all these trigonometrical ratios. Tan theta is equal to ratio of sine theta and cos theta, and sine theta and cos theta are also ratio. So here we are talking about ratios all the time. Okay, so when we have done that, let us do few other things and establish a relationship between um, sine theta and cos theta. So before that, there is some basic which I would just like to emphasize upon. If you look at this right angle triangle ABC, can you recall the Pythagoras theorem? What is Pythagoras theorem? Pythagoras theorem is hypotenuse square will be equal to perpendicular square plus base square in any right angle triangle. This is known as Pythagoras theorem. Pythagoras was an ancient mathematician who established this fact, or kind of discovered this fact. That's why we call it Pythagoras theorem. So our next deduction is based upon Pythagoras theorem. So what we have written, h square is equal to p square plus b square. Suppose this is a equation, and it is true equation for any right angle triangle. Just divide everything, both of the side. This is LHS, left hand side, this is RHS. Divide both of them by h square. We can do that. Why we can do that? Because h square, h is a length of side. It can be only more than 0, and then anyway h square will always be positive and above 0. So without caring about the signs, we can divide both of the side by h square. So what we get? So 1 is equal to p square plus b square divided by h square, or we can also write down p square by h square plus b square by h square, isn't it? And then by the law of power exponents, we can write that p square plus h divided by h square is nothing but p divided by h whole squared. And similarly this one. But have you noticed something? P by h is nothing but sine theta. So we can write, and this is written as sine squared theta. P by h is whole squared is sine squared theta. And in the similar fashion, b by h is nothing but cos squared theta. So this is another formula, you can say, or a kind of relationship, that in any right angle triangle, if we square sine theta and we square cos theta and add them together, then we will get 1. And then there are a few other things also we can say. For example, sine squared theta will be basically equal to cos squared theta. And then similarly, cos squared theta will be 1 minus sine squared theta. So all those things are true basically. It is just a kind of reshuffling between LHS and RHS, left hand side and right hand side. So now we have established a few relationships. Let us just go through them quickly. First of all, we knew that or we learned that trigonometry is a kind of you can say basically the science of study of triangle, or a study of triangles, and mostly 90 degree angle. And then we define trigonometrical ratios. First of all, we define what is base, perpendicular, and height. Afterwards, we defined three ratios: sine theta, cos theta, tan theta. Sine theta is equal to p by h, cos theta is equal to b by h, and tan theta is equal to p by b. These are the definitions of these different ratios. And then we just took Pythagoras theorem and then tried to establish the relationship between these three basic trigonometrical ratios by doing some usual stuff like dividing and equation stuff, you can say. And then we just got one basic relationship, that is sine square theta plus cos square theta is equal to 1. And then we can say that sine square theta will be equal to 1 minus cos square theta, and cos square theta will be 1 minus sine square theta. So these are the basic things which we have learned. We will go into a little bit more detail of the various trigonometrical ratios at some angles which are quite special angles, like and which are those special angles. We'll look into 0 degree, 30 degree, 45 degree, 60 degree, and then 90 degree. So these are maybe one of the you can say the main angles on which we will concentrate, although the angles, this theta angle, can vary and can be anything. It could be 31 degree, it could be 62 degree, or whatever. But just for the simplicity's sake, we will focus on 0 degree, 30 degree, 45 degree, 60 degree, and 90 degree angle. So these all will be the value of theta. That we'll see in the next video. Thanks.